Okay, here we go. We go live. So, hope everybody's having a good day today or had a good start of the weekend and everything. Um, I just had to do a video because I had a discussion that's really kind of highlights my discussion on the variable speed of light, trying to explain to people what's going on. So here we go. Let's go to the content here. And we're off. Let me see what we're going to go up here. Okay. So this comment here is by Simon Hibbs. I guess he's a programmer of some kind. He's a very upstanding guy. He's not argumentative or anything, but he's trying to hold the line for the constant speed of light velocity. So it's a very long discussion, as you can see here. It's 104 replies. Let me see if I can make that larger. Okay, there we go. How's that? There we go. So it's me, Jungle Jogging. It's, I guess it's a whole bunch of people, but I guess it's mostly Simon Hibbs or this programmer. And let me just go ahead and show what I wrote here for the initial comment. So I say there are three rates to consider. And I've had a discussion with him before too, so he already knew me, I already knew him. I mean, he's familiar with him. The diminishing effect or draw of gravity away from the center mass, that's three rates to consider. That's, in other words, the farther away something gets away from a center mass, the less the effect is going to be on it, right? So the farther away it is, the slower it moves. In other words, the planets way, way out, away from the sun and the solar system are moving very, very slow because the effect of gravity diminishes the farther away you get from the center of the mass. So, in other words, things tend to slow down away from the center of the mass of the gravity of a galaxy, of a sun or star, or whatever. So, but that's not what we observe sometimes, which is the reason why they come up with dark matter, is because they think that there has to be some other matter causing the movement, the accelerated movement away from the center of the gravity. Anyway, so the three rates to consider: the diminishing effect or draw of gravity away from the center mass, the increasing rate of time away from the center of mass. In other words, clocks move faster the farther away you get from the center of mass. Clocks move faster. Not only that, the increasing measure of distance away from the center of the mass. Distance stretches or inflates or is inflated, doesn't inflate. It is inflated by comparison to what is closer to the mass. So the farther away you get away from the center of the mass, the more inflated things are going to be, especially distance in relation to distance. Okay, so speed is measured by what? How do we measure speed? We measure it by time, the time it takes to travel a certain distance, neither one of which is constant. So time is not constant. That speeds up away from the center of the mass. Distance is not a constant. That inflates away from the center of mass, both of which change the speed of light and causation. In other words, it'll make things happen faster. Things will be faster and they happen faster because of the change in the rate of time. Clock speed up and distance expands means that you have to travel a larger distance. Okay, distance gets longer without gravity and time goes by faster, both of which speed up causation. The light has to arrive at a farther distance faster when the distance is stretched and time goes by faster. Then after all that, there is the first thing to consider, and that is the diminishing draw of gravity, which means things eventually slow down the farther away they are from the center of the mass of gravity. It's not complicated, right? So that's my initial statement, and he responded by saying, "Oh, it's all already accounted for. They already took into account of all that and everything." But then, okay, so this is comment number 104, I guess. This is what I wrote. I said, I already told you that something going into the event horizon looks stopped to us because of how slow it's moving. He says, you don't have to tell me. I know this is a prediction from general relativity. This is general relativity. The question is, what implications do you think it has for light entering a black hole? The answer is it gains energy. And I'm not talking about the energy or the frequency, which for light means it gets blue shifted, which is true to a higher frequency, right? Light going into a black hole is blue shifted. Light leaving the area of a black hole gets red shifted. But I'm not talking about it. This has nothing to do with what I said. Time for objects close to a black hole runs slower relative to the Schwarzschild coordinate time far from the black hole. So the frequency of light seems to run faster, which means a higher frequency, hence the blue shift. Okay, and he keeps going to blue shift. He keeps going to the frequency, and I'm not talking about the frequency of the light. I'm talking about the speed of light and other things. The speed of causation. It's like a good illustration, but it's not a good example, is that smaller life forms like small shrews and rats and mice, they run in a faster world because their metabolism is faster. But it's not the general relativity. It doesn't have to do with metabolism. It has to do with a faster rate of time, an increased measure of distance, which makes everything bigger, but it makes causation faster. Okay. Okay, so then I say, I already told you the converse is also true, that things moving away from the mass of the galaxy appear to be moving faster than they are. They do, due to an optical illusion effect. I know about that as well. Okay, but he can't admit that it actually speeds up. He says it's an illusion, but he can't admit that it's actually going faster. What you are not saying is what implications you think this has for light. You're just saying there's this observation. Okay, yes. And therefore what? All of these observations are fully explained by general relativity. Well, it's general relativity what I'm talking about, which is basic axiom, a fixed universal speed of light. But that's what I'm explaining, the implications of general relativity and the universal speed of light, as well as the universal speed of light. The universal speed of light does not change. This is what, I don't know, they have such a hard time understanding The speed of light does not change. It's fixed. It's a fixed universal speed of light. It's fixed. Okay, away from the mass of the galaxy, distance is longer and times runs faster. This is me again. This means things happen faster. I told you to do the thought experiment so you can see what is happening. The distance light has to travel in 1 second is stretched, so it's farther, and the second is shorter. Okay. That's what makes the speed faster while maintaining constant speed on paper numerically. Okay, so then his response is the distance light has to travel in 1 second is stretched doesn't make any sense. So he's not getting it. Light doesn't have to do anything. Here he says light doesn't have to do anything. Yes, it does have to maintain the speed of light. It does have to travel at the speed of light in a vacuum. It's not trying to meet a timetable. Yes, it does have to maintain the c. It travels at the speed it does, which is c, which is the speed of light. Which if you stretch the parameters and increase the rate of time, it's going to move faster. What distortion due to gravity does emergence from gravity well is stretching out the wavelength of light. Here he goes back again to the wavelength and the frequency. We're not talking about the wavelength and the frequency. Yes, light moving away from the gravitational well is redshifted. Yes, but we're not talking about redshift. We're not talking about blue shift. Not right now. We're talking about general relativity, time and distance and speed, not wavelength, not frequency. And I don't know why it keeps going back to this. I'm not talking about wavelength or frequency. Okay. What distortion due to gravity does emerging from gravity well is stretch out the wavelength of light as it emerges, and time dilation lowers its frequency. It gets redshifted down the spectrum and loses energy, but the speed doesn't change. But nobody's this is so bad. The measured speed doesn't change, but if the measurements change, it changes the speed. It's just so hard to understand. I don't know why it's so hard to understand. But its speed doesn't change because in terms of its speed, the length and time dilation effects cancel out. No, they don't cancel out. They compound the effect. They add to the effect. When gravitational effects pull on an object, they change its energy by changing its velocity. When gravitational effects pull on an object, change the energy by changing its velocity. The frequencies. When gravity stretches or compresses light, it doesn't change its speed. It changes its energy by shifting its wavelength and frequency. It blue shifts and increases the energy by blue shifting the light. Yeah. Because everything is contracted and time slows down. Okay, so what was my response? This might take some time here, but I don't know why he keeps on going to the redshift. He keeps on going to the frequency. Now this is all the responses here. Zooming right past him because most of them, this guy here is a troll. He keeps on bothering me. He lives and breathes to troll me all day long as much as he can. Okay, there's Simon Hibbs there. Okay, so I'm going through the explanation. might take a long time to get through it all. He keeps on thinking that it only changes the frequency, it doesn't change the actual speed. Well, if you change from kilometers to miles, from 60 kilometers to 60 miles, you're going to change the speed. And if you change from miles a second to miles a half second, you're going to increase the speed again. And this is so hard for them to understand. So it compounds the effect. Now, this is just crazy how long this discussion goes, back and forth, back and forth, back and forth, and they keep on insisting, posting on the same thread, and they keep on coming back. They keep coming back. It's the craziest thing. They just keep coming back. They want more. They want to get destroyed more every time. So don't pay too much attention to the troll over here. So I say troll harder. Troll harder. He ends up calling me a troll, of course, but he lives and breathes to troll me. So this is my response. Okay. If you remember what he said light's not obligated to do anything or something like that. I'm saying light must indeed travel at the speed of light, c. When distance is stretched, light must travel that distance in the time determined by c. That means the light is traveling faster as perceived by us in our more contracted frame of reference. So we don't have the same measures of time and distance as what we were observing in outer space, especially things like plasma jets shooting out from a galaxy. It's not in the same frame of reference as where we are. We're seeing things outside of our frame of reference. We're not seeing things locally. Okay, that means the light is traveling faster as perceived by us in a more contracted frame of reference. Add to that the fact that a second passes by faster, which increases the speed light must travel even more. It's not complicated. It's so simple. It's the very reason things appear to be moving faster than the speed of light, moving away from the center of the galaxy, because they are moving faster, yet without exceeding the speed of light. I don't know why that is so hard to understand. You stretch the distance, the light has to get there faster in order to meet the requirements of the speed of light in a vacuum. And then plus time is going by faster. It means it has to get there and even in a shorter amount of time, which compounds the effect of the changing speed of light as observed by us where we are in our contracted frame of reference. But it's just amazing that people just don't understand it. It's just beyond me how people are not able to understand this. But anyways, I had to go over this again. I had to go over this again just for see see if I could explain it some more and hopefully maybe get some more people to understand what it is, what it involves, what's actually happening in general relativity. The farther away you move away from the center of mass. Brother Timothy, I was listening. There you go. Very good. Nice. And this has implications too. That means that distant starlight is arriving to where we are much, much faster than what they think. It has implication, which is probably the reason why they don't want to admit it. Because that means light is arriving to where we are almost instantaneously. Instantaneous is, which is, that's the reason why they don't want to admit it. They don't want to admit the implications of general relativity. It's just so simple. It's so simple and so easy to understand, and yet they get into all this complicated jargon, and I have to go with simple jungle jargon to straighten out their misunderstandings, because I'm from the Amazon jungle, of course. That's where all the scientific learning comes from, the Amazon jungle, apparently, and not these, palaces of education. Makes Big Bang moot. Yeah. They can't let go. Yeah, it just amazes me how it's so simple to understand, and yet these people supposedly with a high IQ, this is why I keep on harping, I keep on asking for, where are the people with a high IQ of 200, 175, 200? Where are they? Where are they? Where did they go? Where did they all go? They just disappeared all of a sudden. Where are all these people with a high IQ to see and understand general relativity? It just amazes me. That's why the Bible says, he reveals it to, people in the wilderness, people from the jungle, before the educated people. The goat herders were there long before the educated people. The goat herders were already there, They already understood everything long before the educated people learned about it. It's just amazing. Anyways, guess that's good enough for my rant today. I hope everybody has a nice rest of the week. And God bless everybody. And God never fails. His word is true. Absolutely true all the time, 100%. Science is knowing God. True science is knowing God, knowing your creator. Because only your creator can create you again. Nobody else can. That's the absolute truth. There is no other absolute truth. God bless everybody. And we'll see you again soon, if God allows.